I'm debating at this moment whether to go over the range equation. The range equation is a bunch of, well, not a huge bunch of yucky math, but it pretty much takes our trigonometry skills to the limit. We do all kinds of trigonometry, and then at the very end, you go into your trig book and you get one of your trigonometric identities and you figure out what the final solution is. Is that worth doing today? I think it is. I think it is. So, hopefully this will not be a gross waste of your time and that things will actually make sense at the end. In the range equation, we have a delta x, we have an initial velocity, we have an angle, the initial, and delta x. Okay. And we want to find out for a given delta x and v initial, what is the angle? This is actually one of the very first physics problems in real life. Okay? About 5, maybe almost 600 years ago, people started using gunpowder. And they suddenly had a weapon that they could use that had much further range than anything they'd ever imagined before. Okay? Make a really big cannon, shoot it at your enemies, and hope to hit something. Well, 600 years ago, they didn't know how to aim a cannon. Okay, so you want to be able to predict, how far are you going to hit something, and all you've got is the amount of gunpowder you can put in your cannon. The size of the ball is fixed, so you've got, your projectile is just a cannonball, usually a big chunk of rock that somebody has chipped into a relatively smooth sphere. You've got a pile of gunpowder, which is how you control your initial velocity. And then you've got your elevation. We use the time, so let's start off with our component. So let's start off with our kinematic equation in 2 dimensions. Okay? So y as a function of time is equal to our initial y, which is 0, okay, plus vyt, the initial, now vyt, minus g over 2 t squared. And we know that x, as a function of time, is just our initial x plus vxt. Okay. Y at time t, is equal to 0. Right? So what we have is, so this gives us 0 is equal to 0 plus vyt minus g over 2 t squared. So that gives us either t is equal to 0 or t is equal to 2v over g. 2vy over g. Again, we've used the fact that we know our initial y here, and we know what our final y is. Y final, okay? Y final is 0, y initial was 0, Okay, so this lets us this makes this easy because it's not even a quadratic equation, right? Now we put this time into this equation. So x of 2vy over g is equal to 0 plus vx t. Well, t was, so 2vy over g. Okay. So that gives us now delta x is equal to vx vy 2 over g. Okay. Vx is v naught cosine of theta. Vy is v naught sine of theta. All right, and so that gives us delta x is equal to v naught squared cosine theta sine theta 2 over g. At which point we have to stop. Why? Because now we need to do a trig. Now we need to do a trig trick. Now we do a trigonometric trick. And what it tells us is that cosine theta sine theta, that gives us, oh blimey, and I've just reached the end. Okay. All right, so the kinematics equation, do I have the projectile motion equation? Do I have it here somewhere? Because I really want to check it because I don't want to have my rather meager trigonometric skills screw everybody up at this point. Let's see, wait a second. Let's do range equation. Come on, and the range equation is come on, where's the bloody range equation? Projectile motion. Come on. Range equation, range equation, range equation. Oh, for goodness sakes. I really, really don't want to get this wrong, so I'm taking an extra bit of time to find the actual range equation. And I am just not finding it. Time of flight, okay, time of flight, trajectory. Range equation, there we go. Ah, excellent, okay. Okay, so the range equation is delta x equals v naught sine of 2 theta. Okay, so delta x equals v naught squared sine of 2 theta. Sine of 2 theta. Okay, divided by g. Right. And so you can solve this for theta to get x. Desired delta x. Okay. All right, that is it for today. Plan at this moment is to have a comprehensive midterm next week. Let's say Wednesday. Okay, so midterm Wednesday. Wednesday, that is March what? Next Wednesday, what's the date?
22nd.
What?
22nd.
22nd. Thank you. All right, that will be pretty comprehensive. We'll be covering vectors, 2D kinematics, that should include, basic stuff like significant figures, orders of magnitude, just basically the stuff that we've gone through. I will likely be taking test questions from a textbook, which is how we usually do it. Not necessarily that textbook. Your best bet for studying is to do problems. In our regular textbook, college physics, there's a second version of this that's for AP Physics that has the answers for, I think, most of the either even or odd questions. There is a link to that. There's a link to that in one of the homeworks. I'll make sure that that's available. Any questions, comments, complaints? I can think of a few complaints. Yeah.
Can we get our tests back?
Yes. That's why I stopped now, so I could give you things back. Yes. All right. So. Okay. Conceptual physics. All right, here we go. Right, Zachary. Okay, Ryan, did Ryan leave? Ryan left, okay. Mia's not here, okay. David Gong. Gong's not here. Physics 1, right? Yes, okay. Dulce. Eduardo. Hannah. Hannah no here? Hannah's not here. Bryce. Ruben. Aria. Oscar. Morgan. Matthew. Anki. Jared. Dean Jared? Amir. Daria. I do also have Anthony. For those who did not do well on the vector part, David. What? Let's see, this is Angi. Yeah, this is the previous one. Chris. This is okay. So I should have returned. Everything that has been graded should have been returned to you by now, and I don't have anything left in the grading pile. There are a couple of things though. Early on, there were a couple of assignments where people messed up the download,